So we're going to talk about the order transformations because some of the problems were a little bit confusing as to what you should do first. So I'm going to say, and there's a little bit of lack of consensus on some of this. So I'm going to say let's do our reflections first. And then let's do the vertical or the horizontal stretches and compressions. So the lack of consensus is that these could actually interchange and it wouldn't affect it. So as long as you do one of these two first and then you do the other one, and last is you're going to do, and I would just work my way through the problem like left to right. The last thing you're going to do is the left-right shifts. And the up-down shifts. And it doesn't matter if you do the left-right shifts and then the up-down, or if you do the up-down shifts and then the left-right. You just want to make sure that you do these after you've done these. So the first two steps doesn't really matter. You just want to make sure you do this last step, the third step, last. So let's try to hit some of these that came up today in class. Let's do number 5. Greatest integer function. All right, so I'm thinking, do I have reflections? No, there's no negatives. So then I'm going to work on vertical and horizontal stretches and compressions. So I see the 1/2. So first off, parent function is the greatest integer function. This is a 1/2 happening to the x, so that's a horizontal. Horizontal are the sort of opposite of what it looks like. So usually for the vertical, if we're between 0 and 1, it would be a stretch. But for the horizontal, this fraction, between 0 and 1 for vertical would be a compression. But for horizontal, this is a stretch by a factor of 2. You want to do the reciprocal. Then you can do the left, right, up, and down. And so this plus 5, it's happening to the whole function, not in there with the x. So it's up 5. When it happens to the whole function, it's more exactly what it looks like. All right, number 10. All right, so I want us to look for reflections first. And you notice there's a negative. So that negative right there is inside with the x. And you might say, no, it's not. X is here and it's not in there. But we're inside the parent function. We're inside this cube root. We're not out here. So it is inside with the x. So that is if it's inside with the x, it's horizontal reflection. And if you reflect horizontally, you're reflecting across the y. So that's a reflection across the y-axis. And then we're going to deal with compressions and stretches. So that 5 is inside with the x. So it's a horizontal. It's the opposite of what it looks like. It's not. It's a compression. And if you think of the factor, it helps. It's a compression by a factor of 1/5. And then we're ready for left, right, up, and down. So we come to the 9 next. That's in there with the x. So it's a left, right shift. And it's opposite of what it looks like. So it's left 9. And then we'd go to the 4. It's outside of It's not in there with the x, it's outside happening to the whole function, so it's just like what it looks like. It's down 4. Number 11. We've got the parent function graph. So we know we're dealing with f of x as x squared. B part, they want us to translate 4 units down and 3 units left. So this doesn't matter. Left, right, up, and down, we can do those all at the same time. So I'm maybe going to deal with the left, right, because I need to write it in there with the x. So we need to do x plus 3 to handle the left, right. And that needs to be inside with the x. And then we can do the down 4. You could have also done down 4 plus the left shift. Both of those are great. All right, C part, we're going to do vertically stretch by a factor of 2, and then 5 units left. Okay, we got to do reflections first, then vertical and horizontal compression and stretches. So we need to do this stretch. So if we're vertically stretching, we're multiplying all of x squared. Okay, so it's out front of the x squared. But I should have thought about this. 5 units left, that's a left-right shift. It needs to happen in there with the x. So we need a parenthesis, x plus 5, opposite of what it looks like, squared. And looks like there was a question on 14. That's a parent function of x cubed. B part, we're looking at vertical compression by a factor of 1/2. Then reflection on the y-axis. And then translate 4 units right. Okay, so first thing we need to do is the reflection on the y-axis. Okay, so we're going to start with reflection. So reflection on the y has to be a negative inside with the x, so we know we're looking at this. Okay, so maybe I'm just slowly going to build this. I'm going to erase some stuff, but this is my thinking. Next is my compression. So next I'm looking for those vertical and horizontal stretches and compressions. So we have a vertical compression by a half. Vertical is exactly what it sounds like. So it's a half out here. And then we have 4 units to the right. And this is where my left-right needs to be inside with the x. And this is where it might be a little bit confusing. I need to do it like this so it can actually be inside with the x. So I have to add that set of parentheses. So I know people in second period were saying, but if we distributed, wouldn't that be negative x plus 4? But I've watched some videos, and if it happened to look like that, the very first step before they think about transformations is they factor, because they want x to have a, they factor that negative out. So we wouldn't distribute. And I think that'll help if we follow those steps there. All right, there was a request for an even and an odd example. So let me do one for you. Let's do f of x equals the square root of x squared minus 4. I know what square roots look like. I know what x squares look like. I'm not sure what the square root of an x squared looks like. So we're going to do our test. Test is the same no matter what. We plug in a negative x. Be careful when you plug it in. And then when you square a negative, you get positive. And we simplified it. We compare it to the original. See. And we ask, is it the same? Yes. It's exactly the same. So that means it's even. It's exactly the same. It's even. Even functions have symmetry with respect to the y. All right. Hopefully that helped. Let's do one more. Let's do an odd. Now you know it's odd though, don't you? Let's do f of x equals x cubed minus x. So let's do the test. Plug in a negative x. That gives us a negative times a negative is a negative. Remember, a negative raised to an odd power is negative. And a negative times negative here is a positive. So we compare to the original. It is not the same. Is it exactly opposite? Check your first sign. You have a positive and a negative. That's exactly opposite. Check your second sign. You got a negative and a positive. So yes, it's exactly opposite. That means it's odd. Lauren in 6th period said if you take odd and turn it over, or opposite and turn it over, you get odd. So I love that. So that means it's odd. And odd functions have symmetry with respect to the origin. So we've got all of those O's there. You've got opposite, it's odd, and you have symmetry with the origin. It only happens there with the O's. Let me do one thing here. Let's compare that x cubed minus x to this one, the negative x cubed plus x. What we might do is factor the negative out, and you'd be left with x cubed minus x. Then it's even more obvious, I think, that these are the same, and this negative out front means it's exactly opposite. So maybe you want to do one more step and factor the negative out. All right. Hopefully that helps.